All right, today we're starting our next unit, Unit 16, which is going to be on slope. At the top of the page of your page of notes, you need to write the title of the lesson, Slope of a Line. And today we're only going to be learning how to find the slope of a line from a graph, so put graph in parentheses. And then our EQ for today, how can I determine the slope of a line from the ratio rise over run? Slope is something that we've actually already learned earlier this year, but we called it a different name. So today we're going to be learning what slope is and how to find it from a graph. So make sure you've set up your notes with the title and the essential question. Hit pause if you need another second. When you're ready to move on, hit play. All right, go ahead and copy this into your notes. When I said a second ago we've already learned how to find the slope, we called it a different name. It's been several months since we learned about proportional relationships, which is what this connects to. So I do want you to write all of this in your notes. So hit pause real quick and copy, and then I'm going to talk through everything with you. Let's review proportional relationships since it's been quite a while since we learned about this, and we're actually going to be coming back to this as SC Ready Review in a couple weeks after spring break. But here we go for now. Proportional relationships can be shown in a table, graph, or equation. So how can a table, graph, and equation show a proportional relationship? You need to know each one. First, a table shows a proportional relationship when one quantity is a constant multiple of the other quantity. What that means is for every single row in the table, if we look at x, we should multiply that x times the same number to get y for every single row in the table. So we did that, and we found what we called the constant of proportionality from that. If you remember, if that sounds familiar to you, constant of proportionality. Next, we looked at a graph. And remember, a graph shows points with a proportional relationship if a line that passes through the origin can be drawn through the points. Remember, it has to be a straight line graph that passes through the origin. That would be a graph of a proportional relationship. And then the equation that we wrote for a proportional relationship is in the form of y equals mx, where m was actually a number that we called the constant of proportionality. So all of this we learned several months ago. In those spiral reviews I've been assigning to you each week, you have had review questions from this, but we haven't talked about it in a while. But this is actually going to connect very closely to slope, what we're learning about in this unit, okay? If you're not done copying this down, hit pause and finish copying. When you're ready to move on, hit play. Okay, so remembering, you don't have to write this down, just look at it with me. Remembering how to tell a constant of proportionality from a table, you would do y divided by x. So 2 divided by 1 is 2, 4 divided by 2 is 2, 6 divided by 3 is 2, so the constant of proportionality is 2. We could write the equation y equals 2x. Remember, we put the constant of proportionality right next to x. And then for the graph, we would plot these points on the graph over here, and we're looking to see, is it a straight line graph? And does it pass through the origin? That was how we found a proportional relationship. So that's just a review that goes with the last slide. All right, new notes for today, linear equations. I need you to copy both of these things into your notes, to hit pause real quick and do that. How do I represent a proportional relationship in an equation? The graph of a proportional relationship is a line that passes through the origin. The equation y equals mx shows that y is always a constant multiple m of x. And what is a linear equation? It is an equation in the form of y equals mx. It's an example of a linear equation. Equation is a linear equation if the graph of all its solutions is a line. So what we're looking for a linear equation is when we plot all those points on the graph, does it make a straight line? Okay, so for a linear equation, it's not exactly the same as a proportional relationship because it does not have to pass through the origin. It does have to be a straight line, but it does not have to pass through the origin. All right, hit pause if you haven't finished copying this down. All right, the number of words y you can type in x minutes can be represented by the equation y equals 55x. The number of words your friend can type in x minutes is modeled by the graph. Which of you can type faster? So what I want to do is look at the graph and figure out what this friend's constant of proportionality, or like their unit rate was. So I'm looking for a point on this graph, and any point's going to give me the same answer. So I see right here, my board will write, hello. There we go. I see a point right here, and the point is the y value is 150. The x value is 3. Remember, we always do y divided by x. We learned that back in our unit on proportional relationships. So my y value is 150, and that is the number of words. And then x is 3 minutes. Now that's one kind of rate, but I want to know what the unit rate is. How many words per minute would our friend type? So I would divide 150 divided by 3. And that is 50 words per minute. So comparing this unit rate to looking at this equation, I know my constant of proportionality is this number right here. So my words per minute is 55 words per minute. My friend's is 50. So which of you can type faster? Me. I can type faster. I can do 55 words per minute, whereas my friend can type only 50 words per minute. I got that from this table, okay? Or from this graph, I'm sorry. All right, more notes. I know it's a lot for today. You'll be okay. Slope. This is the big thing for today, and really for this entire unit is slope. So write down the definition for slope, and then you need this little formula right here. I'm going to circle it. You need to also copy down the formula. Okay, what is slope? Slope just describes the steepness of lines in the coordinate plane, which means on a graph. The slope of a line is a ratio of the vertical change, which is like the change in y, over the horizontal change, which is like the change in x, okay? So this is our slope formula. And for graphs, we are going to use kind of a nicknamed, I guess, formula. We're going to call it rise over run. Rise over run is our slope formula. When you rise, which direction are you moving? You are moving up or down, okay? So we're, for the rise, thinking about how much do we go up or down. And then for the run, which direction do we run? We run sideways, left or right, okay? So we're counting the vertical change is what we call the rise. How much do I go up or down? And then the horizontal change, we're calling that the run. How much do I go left or right? So looking on this graph, if I were to find the slope of this line, I'm using this formula, vertical change over horizontal change, or like I said, kind of the nickname for that is rise over run. I'm going to start at this point right here, which is where it's crossing the y-axis right here. And I want to count, going from this point to the next point on the graph. First, how much do I rise? How much do I go up? I go up 1, 2, 3. So we put a 3 for the rise, for the vertical change. Then from there, how much do I run? I go sideways, 1, 2. So I put 2 for the horizontal change. So the slope of this line is 3 over 2. Let's try another example. Okay, for the first example, and I want you to write this in your notes. You don't have to copy the graph, but I do want you to write the slope in your notes. So I'm starting at this point and I'm going to this point. I am going to rise first, and I go up 1, 2. Then I'm going to run this way, 1, 2, 3. So my rise was 2 and my run was 3. The slope is 2 over 3. Okay? Next, I'm going from this point to this point to find the slope. So I have to count how much do I go up. I go up 1, 2, 3. I'm going to write that out to the side. Then I go over 1, 2, 3, 4, 5. So my rise was 3, I went up 3, and then I went right 5. My slope is 3 over 5. All right, looking at the third one. Notice that this line is different from the other two. How? These lines were going up from left to right over here, up from left to right, up from left to right. When you're looking at the graph and you see that the line is going down from left to right, that is going to mean that the slope is actually going to be a negative number, okay? So when you look at it, when the line is going down from left to right, that means the slope is going to be a negative number. So I'm going to go ahead and put a negative for my slope. And I'm going from this point to this point. I always go from the lower one to the upper one. So I'm going to go up 1, and then I'm going to go left this time. 1, 2, 3, 4. So my rise was 1, my run was 4. And again, how did I know that the slope would be negative here? Because I see that this line, when I'm looking from left to right, it's going down. So my slope would be negative 1/4. Okay, so again, what is the little formula I taught you to find the slope from a graph? Rise over run. Try this one on your own. I'm not going to do it with you. Hit pause and find the slope on your own. When you're ready to check your answer, hit play. All right, we're going from this point to this point. And I see that my line is going up from left to right, so I know it's a positive slope. I'm going to go up 1, 2, and then I'm going to go right 1. So 2 over 1, which is actually the same thing as just 2. I know anything divided by 1 just gives me that number as a whole number. So 2 would be my slope for this line. Okay, let's try one with words. You might have one like this on digits. As the x-coordinates increase by 2, the y-coordinates decrease by 5. Then your other friend describes the slope as the x-coordinates decrease by 2, the y-coordinates increase by 5. Let's write each of those slopes. So we know it has to be the change in y over the change in x, which is like rise over run. Okay, so this is the first friend. They said that the x-coordinate increases by 2, so I'm going to put 2 for x. And the y-coordinate decreases by 5, so I'm going to put negative 5 since they said decreases there. That means goes down, okay? My other friend says that as the x decreases by 2, so for x I'm going to put negative 2, and then the y-coordinates increase by 5, I'm going to put positive 5. Are these the same thing? What is a negative divided by a positive? Negative divided by a positive is a negative. What's a positive divided by a negative? A negative. So these are actually the same thing. You can either have the negative on the top of the fraction or on the bottom of the fraction, and they both mean that it's just negative 5 over 2. Okay? So either of those would mean the same thing. All right. At this point, you should be ready to start on the digits. Now, since I only went over how to do the problems with graphing, you only need to do the first 5 problems from the digits assignment today. You're going to do the rest of it with the lesson you'll do tomorrow. Once you finish that, get started on the Unit 16 IXLs that are on Google Classroom.